Blockchain. Blockchain is a shared digital ledger or record book where transactions are written in a secure, transparent, and unchangeable way. Key features include decentralization. Unlike traditional systems managed by a single authority, example banks, blockchain operates across a network of computers, called nodes. No single party controls it. Transparency. Everyone in the network can view and verify the transactions, making it difficult to cheat. Immutability. Once a transaction is added, it cannot be altered. This ensures the integrity of the data. Everyday example. Imagine a group of friends playing a card game. Each round scores are recorded in a shared notebook. Everyone has a copy so no one can cheat or change previous scores. How blockchain works. Transaction initiation. Someone requests a transaction such as sending money or signing a digital agreement. Broadcasting. The transaction request is sent to all computers, nodes in the blockchain network. Verification. The nodes check if the transaction is valid using predefined rules. Example, does the sender have enough funds? Block formation. Verified transactions are bundled into a block. Each block contains transaction data, a unique code called a hash like a digital fingerprint, the hash of the previous block for linking. Consensus mechanism. The network agrees on the validity of the new block using algorithms like proof of work or proof of stake. Block addition. The block is added to the chain, making the transaction permanent. Key concept. The blockchain is a continuously growing chain of blocks, each linked securely to the previous one. Key parts of a blockchain. Blocks. Think of blocks as pages in a ledger. Each block records a group of transactions. A block includes data, the transaction details, hash, a unique code generated from the block's data. Previous hash links the block to the one before it, forming the chain. The chain, the sequence of blocks linked together. The chain ensures order and prevents tampering since altering one block would break the links. Nodes. Computers that store copies of the blockchain and validate transactions. Nodes work together to maintain the system's integrity. Consensus mechanism. Proof of work (POW). Nodes solve complex puzzles to validate transactions, secure but energy intensive. Proof of stake (POS). Validators are chosen based on their stake ownership in the system, which uses less energy. Types of blockchains. Public blockchain, open to anyone with an internet connection. Example, Bitcoin and Ethereum. Best for transparency and decentralization. Private blockchain, restricted to specific users. Example, used by companies to manage internal processes. Faster and more controlled but less decentralized. Consortium blockchain, managed by a group of organizations. Example, banks sharing a system to process payment, combines control and collaboration. Hybrid blockchain, mixes public and private elements. Example, a supply chain system where internal data is private but shipment status is public. Why blockchain is useful? Security. Data is protected using cryptography, encoding information so only authorized parties can read it. Transparency. Everyone can see the transaction history, reducing fraud. Efficiency. Removes intermediaries like banks or brokers, speeding up the process and lowering costs. Decentralization. No single point of failure, making the system resilient. Immutability. Past records cannot be altered, ensuring trustworthiness. Where blockchain is used. Cryptocurrencies. Bitcoin and Ethereum allow peer-to-peer digital payments without banks. Supply chain. Tracks goods from production to delivery, ensuring authentication and quality. Example, knowing if your coffee beans are ethically sourced. Smart contracts. Digital contracts that automatically execute terms. Example, paying for a car when ownership is transferred. Healthcare. Securely stores medical records, giving patients control over who accesses the data. Voting. Ensures tamper-proof and transparent elections. Challenges of blockchain. Scalability. Current blockchains handle fewer transactions per second compared to systems like Visa. Energy use. POW systems consume large amounts of electricity, raising environmental concerns. Complexity. Understanding and using blockchain requires technical knowledge. Regulations. Laws governing blockchain are still evolving, creating uncertainty. Security risks. Although secure, blockchains are not immune to attacks like a 51% attack when bad actors control most of the network's computing power. What's next for blockchain? Layer 2 solutions. Technologies like Lightning Network make blockchain faster and cheaper to use. Energy efficiency. Transition to POS systems to reduce energy consumption. Wider adoption. More industries are exploring blockchain for real-world applications. Interoperability. Connecting different blockchains so they can work together. Regulatory clarity. Governments are introducing clear rules, paving the way for mainstream adoption. Recap of blockchain. What it is: a shared, secure digital ledger. How it helps, builds trust, improves security, and increases efficiency. Where it's used: money, tracking, contracts, healthcare, voting, and more. Challenges include scalability, energy use, and regulation. Key takeaways: blockchain is reshaping how we store, share, and trust data, and it's a versatile tool with applications in finance, supply chains, healthcare, and more. Thanks for watching.